here is a guy named Mike, and he works for FedEx. And Mike pushes boxes across the concrete all day long and gets very tired from pushing them. So today he decided, how about instead of pushing the boxes on top of each other like I've been doing and stacking them up, what if I just lay them down on the ground flat and then push one into the other, into the next, and then slide them to the door? Would that be easier? So today we're going to look at the static force acting against Mike as he pushes these boxes to the door. We're going to see if that is less productive than that, or if it's not any different. So let's see. In this scenario, we are going to say that these boxes that Mike's been pushing around are solid wood boxes. So it's a wood box acting on a concrete floor, and our coefficient for stack friction is going to be 0.62 in this problem. It's important to remember that we have the force of stack friction is going to be equal to the coefficient of stack friction times the normal force, and this is going to give the maximum static friction, because if Mike doesn't push these boxes and he has no force fighting against these boxes, if this was the force of stack friction, then these boxes would be just sliding backwards, but that was not going to happen. So this is the formula for the maximum value of stack friction that these boxes are going to have, and this is the force that Mike's going to be having to act against in this process. So the first thing we're going to do for set 1 is find the normal force that is acting in this formula. We have the masses of the boxes times the vector of the gravitational force times our 1, and we're going to have a force of 284.2 newtons. According to this picture, it's going to be a negative value, but this is the normal force, and once we put it into the formula, we're going to use the magnitude of that, and we're going to use our coefficient for static friction maximum of 0.62 for wood on concrete surfaces to find a max static force vector of negative 176.200 newtons that Mike has to fight against. With the second set, we have the boxes lined up in a line, so we have 3 different static frictions fighting against Mike as he's pushing these boxes to the door, and we see that 0.62 is our coefficient for static friction. We have that, and all of these are the formulas the same. Then we have our masses, which vary, and we come out with these 3 different forces for the maximum force of static friction fighting against Mike. We sum all of these forces together, we come up with the same value for the force of static friction's maximum fighting against Mike of negative 176.200 vector newtons. So for this case, in order for Mike to start these boxes in motion, no matter what way they're set up, whether they're stacked, if they're lined, it's going to require a force of greater than 176.2 newtons to break the static frictional force holding the boxes still. So sadly for poor Mike, according to Leonardo da Vinci's discoveries of static friction, no matter how arranged, the static force of friction is directly related to the coefficient of static friction times the normal force. So whether or not the boxes are stacked, if they're lined, they still have a mass, they still have a normal force, they still have a frictional coefficient, and the force of static friction maximum is going to still be the same for Mike.